Okay, so I want to walk you through this project I've been working on. This is my Bender robot. It's an automatic bartender, and we just got our boards back. So I've been playing around with the electronics, and I'm going to walk you through the electronics and show you how they work. So power comes in from this power supply, and if you follow this 24-pin connector, it connects to this board. This is our power board, and it also has breakouts to Hall effect sensors. It has a breakout to the main power supply switch. So that's actually this guy here. So if I switch this on, we see that that green LED comes on, and that's a power good LED. Then we have let's see, so these connectors here all break out to Hall effect sensors. Over around here, this guy connects to a motor, and this 3-terminal Molex connects to a big red button, which is this guy right here. And you can see this guy's got an LED built into it as well. If we follow the power route, the power goes over here to an Arduino breakout board. This Arduino breakout basically takes in two RJ45s, so this is some signals coming from the pass board that we looked at, and some signals coming from another board that we're going to look at in a moment, and just feeds them to digital inputs or digital outputs on the Arduino. Then if we go back here and follow the other power line to this board, this is a pretty populated board. This is the valve board as well as the LED board. So you can see these two big H bridges over here. Those basically go out to valves, and then these other Molex over here break out to a string of 3 blue LEDs. And the RJ45 connector again is just for its digital signals. So yeah, that's an overview of the board. Okay, so now that we've got to see an overview of those boards, I'm going to walk you through some of the software that I have set up. So this, let me clear this screen here, because that is old data. Okay, so I wrote a little terminal script where I can control the Arduino via serial and give it commands to get it to do things, basically to test all of my electronics. So if I type H, I see I've got all this help stuff. So let's start from the top. So turn motor. So if I hit Q, you can sort of hear it, but here's my motor, and it's turning clockwise, sure enough. And right now it's running at the fastest speed, which this motor is a geared DC motor, so it's running at 15 RPM. I can change the direction by hitting W, and now you see it's rotating the other way. Then I can turn the motor off by hitting E. Motor's off. You can probably hear it's turned off, and then I'll hit W again to turn it back on. And then we can do things like decrease the speed. So if I hit R, and actually I'm just going to hit R a bunch of times so that we decrease it pretty dramatically. Cool. Now I'm going to hit R a few more times. So we can see we're pretty much at half speed now. So if we look at it, it's moving a lot slower, and it probably isn't as noisy anymore. Cool, so motor's up and running. I'm going to go ahead and stop that motor. Okay, moving on to the next guy. We can get the values of the Hall effect encoder. So the Hall effect sensor is this guy right here. And actually I have the Hall effect triggered to an interrupt. So if I actually just grab a magnet and approach one side of this guy and then take it away, we should see on the screen, we see that it detected Hall effect 5, and then when I removed it, it removed Hall effect 5. So that was triggered through an interrupt. Yep. The same goes for the button, actually. The button is also on an interrupt. So if I press the button, and notice the light turned off when I press the button, we get some button pressed. Oh, I don't know why it came in 5 times. Maybe something's up with my interrupt, but it should actually only come in once. Let's see. I'm going to hold it. Okay, I'll dig into that. Let's see, what else do we have? Let me hit H again. Okay, the valves. So right now I have a single valve hooked up, but I've tested all of the ports. And this valve is on valve 7 right now. So if I press 7, you hear that tick. That's the sound of the valve opening. That's the sound of the valve closing. Open, close, open, close. Cool. Lastly, I actually have one of the LEDs hooked up, and instead of just turning on the LED, I'm going to hit P, and what P does is it pulses it. So what we're doing is we're sending a pulse width modulation to the enable on the decoder to the LEDs in order to increase and decrease the brightness of the LEDs. So if I hit P, you can see this blue is pretty bright. And it slowly goes down, quickly comes up. So it's kind of got that breathing effect right now. So that's pretty much all of the electronics for this board. Everything's hooked up, everything's tested, and I'm pretty happy with it so far. So thanks for watching. Bye. Okay, so playing with the button, you know, one thing that you have to keep in mind with buttons like this is you need to have some sort of debouncing. I mean, I have debouncing already laid down hardware. There's a cap here and a resistor back there. So I had tested it before and it had worked. So I was a little bit confused why it didn't work that last time. And it's sort of weird, but what I ended up doing, and I don't know if you can see this. So, let's see, up here. See, I am attaching an interrupt to the magnet, and I'm also attaching an interrupt to the button press. And I noticed that if I comment out the attach interrupt to the magnet, then magically the button works just fine. I only get one button press. So something's going on with their interrupt handler, or maybe my debouncing isn't working as well as I thought. So I ended up adding a software interrupt, or I'm sorry, a software debounce. And so now things are looking good. So if I clear my screen and just go ahead and press the button once, we get button pressed once. So that's fixed. Alright, thanks for watching.